All right, welcome to session 2 for lesson 11. We're going to continue subtracting decimals and go over a few more techniques on how to do that. While these techniques may not be practical, they help give us a better understanding of the numbers involved and what they represent. So let's start with a warm up for this one. All right, so we have all these expressions below, and we want to split them up into two different groups where they're equivalent or equal to each other. Again, equivalent just means equal. So I'll do these in different colors. So we'll do 4 and 60 hundredths. And I know 4 and 60 hundredths looks like that. So we want to find any numbers down here that are equal to that. The other group we're going to make, I'll circle in blue, is 4 and 6 hundredths. And that is going to be any number that's equal to that. So let's look and see what we have here. Let's start with 4 and 60 hundredths first. I know, so we want equal 4.6. Oops, I see what I did there. 4.6 or anything that's equal to 4.6 because 4 and 6 tenths is equal to 4 and 60 hundredths. Because if we just reduce that 61 hundredths, that becomes that. So we're looking for anything that's equal to that. So I'm looking at this one right here, and I'm looking at this guy right there. 4 and 6 hundredths looks like this, 4.06. So that would be this one and this one as well. So again, three different ways that you can write them. You can write them in word form, expanded form, or your traditional decimal. But just be careful of the wording because 60 hundredths is definitely different than 6 hundredths, as you can see. So just be careful with that. All right, now that the warm-up's done, let's go into our workbook. Let's open up to page 209. And let's see what we've got here. All right, Marty eats 2.05 ounces of cheese from a 4.6 ounce block of cheddar cheese. How many ounces of cheddar cheese are left? So this one we're going to do slightly differently, mainly so we get a better connection on how to create a mixed number from a decimal. So let's set up our problem like this. Let's put 4 and 6 tenths minus 2 and 5 hundredths. Okay. And one of the reasons we say decimals properly is then it makes it easier for us to write them as a mixed number. And remember, a mixed number are whole numbers with a fraction. That's why they call it mixed, because you're mixing two different things. Like if you're mixing two different paint colors, that's mixing. If you're dealing with the same color paint, it's not really mixing anything. Okay, so this to turn 4 and 6 tenths into a mixed number, we look at our whole number, which is 4, so that's our big number. And then this is 6 tenths, or 6 over 10. And for this one, we have 2 as our whole number, so we put a big 2 here. And this is 5 hundredths, so 5 over 100. So to subtract these numbers, we need our denominator, our bottom number of the fraction, to be the same, which means we're going to have to change one of these to make them the same. The easiest way to do that is to make this one on the left bigger. So change this to 60 hundredths. Add zeros to top and bottom. So that gives us 4 and 60 hundredths minus 2 and 5 hundredths. And then finally, we do our 4 minus 2, which is 2, and 60 hundredths minus 5 hundredths, which gives us 55 hundredths. And that as a decimal is 2 and 55 hundredths ounces. Now, we are not doing fractions just yet, but this is a great preview of how we will be subtracting mixed numbers later on. So that's kind of why I wanted you to try it out this way. Not the typical traditional way, but an alternate way that we can do it. All right, go ahead and turn the page. Okay, up at the top there. All right, you can also subtract decimals using base 10 models. Again, if you were here in my classroom, I'd be handing these base 10 rods and flats and cubes out for you to use. But we have down here 4 wholes and 6/10, which is, and then these crossouts here are showing how you would remove 2 and 500s, just like our subtraction problem. So again, this is a visual representation of 4 and 6/10 minus 2 and 500s, like that. That's what those crossouts represent. So kind of interesting way to do that. And we'll go back to these once we start the questions on the next page. And the classic setting up your problem in a place value chart is another way to do it. As of note, now they are, one of our original numbers is 4 and 6/10. Remember, you can fill in this spot here on the place value chart, and that becomes 4 and 60 hundredths. So again, just like we were talking about with our warm up, it talks about here where your 4 and 6/10 is the same as saying 4 and 60 hundredths. And that's represented right up here in this top part. And then they kept the same numbers for the subtraction part of the amount that was eaten of the cheese. All right, let's look at the next page. All right, question 1. So look over to the left at those base 10 blocks. Look at the base 10 models and picture it. Explain why parts of the models are crossed out. Because it's the 2 wholes, and they call them flats. And 500ths. Represent 2.05. So they're literally doing a subtraction problem where they're subtracting or deleting that amount from it. According to picture, how many ounces of cheese are left? Well, that's easy because we've solved that before. 2 and 55 hundredths ounces. Look at the place value chart and model it. So it's over at the left at the bottom. You can subtract the decimals without a place value chart by stacking them vertically, that's the end goal. This is exactly how we want to be doing them. Line up the decimal points to keep track of place values. Easiest way to do that is do your decimals lined up. But again, you can take any whole number and then add a .0 next to it to change it to a decimal, by the way. Okay, so this part, explain why you cannot subtract the 5 from the 6 when finding the difference. And what they mean is, why can't we subtract this 5 from the 6? And you probably noticed right away that they're not lined up on top of each other, which means they are different place values. Number 4, another way to express 6/10 is 5/10 plus 10 hundredths. So you can rewrite the problem as shown at the right. And what they're basically saying in this sentence is what happens when you borrow, when you have a bigger number on the bottom. Complete the subtraction. There are 2.55 ounces of cheese left. Because again, you notice here we have a bigger number on the bottom. So we had to borrow from that 6 over there. And that's why that 6/10 is really changed to 5/10, plus we created that 10 hundredths right there. to have something so we'd actually subtract. And number 5, explain how to subtract 2 decimals. Line up the digits by place value. Subtract in each place. By place, I mean by their place value. And regroup / borrow if necessary. Should be enough. So there you go. So that's just your general rules for subtracting whole numbers or decimals. Line them up by place value, subtract in each place, and regroup or borrow if necessary. All right, we can cross out 6 and then go on to 7. So turn the page. Okay. Anya has $3.07 in her change purse. She spends $1.15 on snacks at the vending machine. How much money does Anya have left? Show your work. Okay. This is just a classic money problem. Money's always deals with decimal places. And the great thing is it only uses 2 place values for cents. So you kind of always guaranteed to line up your numbers properly. So here's our problem. Okay. And start at the right. 7 minus 5 is 2. Next, in the tenths column, excuse me, we've got an issue because our number at the bottom is bigger, so we have to borrow from over here from the ones. So we borrow from there. That creates a 10 up here. 10 minus 1 is 9. Break down your decimal point. 2 minus 1 is 1. And she has $1.92 left in her change purse. Question 8. Destiny is sending a box to a friend. The box weighs 23.5 pounds. Destiny removes a 4.47 pound book to decrease the shipping cost. Because anytime you go to the post office to send a package, they put it on a scale and it depends on how much it weighs, how much your postage is going to be. So she's trying to save some money here. Didn't have enough money. What's the new weight of the box? Show your work. Okay. So again, we have 23.5 pounds, and we're taking out 4.47 pounds. Rules for subtraction mean we put our larger number up top. And this is a case where we line up the decimals. And the way I keep track of that is I put my decimal point down here for the second number. And that way I make sure I copy everything just right. And as you'll notice, there is this gap up here, and we can put a 0 right there and set that up like that because 23.5 is equal to 23.50. Keep that in mind. So to also show that 23.5 equals same as 23.50. You can just slash those off and you can see it's the same. But anyway, all right, let's get started. Already we have a bigger number on the bottom. So we're gonna have to borrow from the next place value over. And that creates a 10. 10 minus 7 is 3. 4 minus 4 is 0. Bring down your decimal point. All right, so we already borrowed. We didn't need to borrow again, so we cleared that up. But we are in another situation we have to borrow because the number on the bottom is bigger. So let's borrow from here. Bring that 10 over here to give us a 13. And 13 minus 4 is a 9. And 1 minus nothing is 1. So the box that she sends out is 19.3 pounds. Again, just taking your time with subtraction, you should do just fine. And last problem for today. What is 241.3 minus 81.55? Let's So let's write this over here. Got plenty of space in your book for that. All right. And like I said, I usually bring that decimal point down first before I do anything. And line up my number. And again, I have a situation where I should put a 0 right there to fill in my gap. All right, so let's get started. Bigger number in the bottom, so I have to borrow. The thing is, I'm borrowing from over here. That creates a 2, so let's leave that for now. Bring the 10 over here. 10 minus 5 is 5. All right, and let's look at this again. So now we have a 2 up top and a 5 below. So that means we're going to have to borrow again. So let's do that. Changes that to a 0. This becomes a 12. 12 minus 5 is 7. Bring down your your decimal. Bigger number on the bottom again. So let's borrow from over here. That becomes a 10. 10 minus 1 is 9. And you guessed it, bigger number on the bottom. What's going on with this question? Changes to a 1, changes to a 13. And 13 minus 8 is 5. Finally, no borrowings here because we basically have a 0 underneath here. So 1 minus 0 is 1. And that gives us 159.75. And lo and behold, that is one of our options right here for letter D. So again, taking your time, writing your problems out neatly is also going to be very helpful in doing problems just like this bad boy over here. All right, your homework. IXL activity H3, that is going to be a combination of adding and subtracting decimal numbers. So it's basically just going to take problems from H1 and H2 and just combine them. So you just have to be careful and make sure you're paying attention to the signs for each problem. And you shouldn't have any problem with that. But if you do, I'll be available for help. You just need to let me know.